SpaceX Dragon on Dragon to ground. We're complete in 4.010.
Copy, complete with 4.010 for suit donning. At this point, you are go to begin your suit leak check procedure.
We'll put 4.011 in work.
And so with that, the crew are going to step into leak checks again. This is going to be their third one. They've already done one when they initially got suited up in the operations and checkout facility, another one once they climbed into Dragon when it was still on the pad and connected their suits via umbilical to the seats in the Dragon spacecraft.
SpaceX Dragon in 2.2, we are ready to pressurize.
And Dragon SpaceX on Dragon to ground, you are go to pressurize.
Okay, visors are down. We'll put that in work.
So now the crew are going to step through and pressurize. Normally when the suits aren't pressurized, they can keep one of the zippers kind of just cracked open, and they're able to just flow cabin air through the spacesuit itself just to provide some cooling while they're inside. We can either flow nitrox into the suits. You could do that if you had a contaminated environment on board the Dragon spacecraft. It's something we also look for on the space station, and they had some air samplers out a little bit earlier just looking for any trace contaminants in their breathing atmosphere. The suits also can have pure oxygen flown to them or flowed to them should the cabin itself depressurize. That'll happen below a certain PSI threshold as we don't pressurize the suit all the way up to 14.7 psi. You would be in essentially a pretty big balloon, and it'd be really hard to move. So they pressurize it to a much lower threshold, and just to make up for the lack of oxygen, therefore in a lower density air, you'd be flowing them pure oxygen. So those suits just serving as another barrier protection for the crew for anything like a contaminated atmosphere or a depressurized cabin inside Dragon. But crew suited up now. Sounds like we're about to step through these leak checks.
Yeah, and we were talking a little bit there. So as you're listening to comms, there's some call outs for 4.010 and 4.011. Those are referring to procedures that the crew have on the spacecraft. So they have procedures built into their displays. These two just happen to be the two that they're running right now. They also have those on their tablets, so they can follow along there if they needed to. If you don't have an engineering background, the atmospheric pressure at roughly sea level, sometimes referred to as 1 atmosphere, is roughly about 14.68 to 14.7 psi. So if you're at sea level right now or pretty close to, what you're walking around in is 14 pounds per square inch of force about on your body.
While those leak checks are in work, the station itself is in the docking attitude. We get to do a pretty cool thing with station during the docking of the Crew Dragon. Normally, the station's attitude or which way it's pointing is controlled by these very large gyroscopes called control moment gyros. And it's a pretty efficient way, only using electricity, to keep these large gyros spinning, pointing in opposite directions to help stabilize the station. It's a very large spacecraft, so using thrusters a little more work intensive. We actually switch over to the Russian thrusters during the initial docking of the Dragon spacecraft, and then after that...
SpaceX Dragon on Dragon to ground, we saw 2 good leak checks.
And Dragon SpaceX on Dragon to ground, we saw the same. Great news, thanks.
And we just got confirmation 2 good leak checks on those suits, so another milestone down as they continue their approach. But just to finish that thought, we're on Russian thrusters right now, controlling the attitude on board the space station. We'll flip over back to the control moment gyros, so those are over on the U.S. segment once we make that initial soft capture, just because we don't want, during that final pull-in of that soft capture ring before we get to that ready to latch, the thruster controls of the attitude can be a little bit more jarring, so we switch back over to the control moment gyros and then let Dragon resume its hard mate. But all that coming up in just about 2 hours, hopefully, away from our targeted docking time, right around 7:30 a.m. Pacific here in Hawthorne. But everything continuing to go well. We have that approach initiation burn happen about 16 minutes ahead of schedule. In just under 8 minutes from now, we'll do our mid-course burn, and then we're standing by for that arrival at waypoint 0 in just under 28 minutes from now.
Dragon SpaceX on Big Loop. The ground is go for approach 2. We will be enabling the resume shortly. As a reminder, ensure your visors are closed prior to Dragon's departure from the waypoint. And once Dragon is inside the crew hands-off point, retreat and breakout are not permitted. And for your awareness, we have sunset in a little less than 8.5 minutes.
Dragon copies all on the Big Loop. Go for docking.
Copy, visors down.
With the crew confirming their visors down, we should see the final approach resume.
Station Dragon on the Big Loop. We are inbound from approach 2.
Copy, inbound.
Station copy.
And we're going to be racing that sunset. The approach has resumed. Dragon closing in. We're inside 20 meters. And yeah, that crew hands-off point should come up in about 3 minutes or so. Right before we get that final docking, it comes about 20 seconds prior, or just about 2 meters away from the station still. And that's just the crew not issuing any abort commands. At that point, it would be too late. And so any aborts would be executed automatically by Dragon itself. So we're closing in at less than 1/10 of a meter per second at this point.
You can see the service section Draco is just doing all these very small, minor attitude corrections. Really, the autonomous docking system at work, making sure that the vestibule and the soft capture system is lined up with IDA2. It's the International Docking Adapter. You can see much more clearly there the hinge mechanism for the nose cone. Those 4 black circles are the forward bulkhead Dracos, not to be used at this time. And then, of course, the pedals of the soft capture system. Wow.
Dragon on the Big Loop. We're inside 10 meters. We cannot make out the docking target, but we do see the outline.
We copy and concur, 10 meters.
All right, we're less than 10 meters away. Again, we're closing at that rate of less than 1/10 of a meter per second. We should be just about 1 minute, 45 seconds away from docking.
There is a center line camera right in that middle, so that you can see where the forward hatch is, and right in the middle of that there's a window and there's a center line camera that is aligned with the center of the vehicle and the center of the docking mechanism. So that is what the autonomous docking system is using to line up with sort of a cross hatch, cross target on the docking port. Again, the forward docking port on PMA2, or the pressurized mating adapter.
And we are just 5 meters away. Again, we're racing that sunset. This Dragon continues to close, 4 meters to go.
Those shadows of the space station on the vehicle. Yeah, you can actually see the centerline camera pretty clearly there, sort of with the contrast of the sun right now.
3 meters to go. Two meters. We are inside the hands-off point, the chop, the crew hands-off point. 1 meter to go. Soft capture complete.
Dragon and SpaceX. Soft capture confirmed. Stand by for retraction and docking.
Yeah, and so the next step here is once the soft capture ring is retracted, there are 12 latches that we refer to as hard capture latches. Those are what will really create that pressure tight seal between the Dragon spacecraft and the International Space Station. So once soft capture is complete, and I believe we'll get that call from our core here, Anna, then we'll get confirmation of hard capture, and the crew, of course, aboard have this information on their displays, so they'll also see indication of hard capture complete.
That's right, and we're expecting to hear some words from everybody. A pretty monumental moment. I mean, for Doug Hurley, he's returning to where he last docked almost 9 years ago on the very last space shuttle mission, now commanding the very first commercial spacecraft to deliver astronauts to the International Space Station.
So right now, the vehicle confirming that the soft capture system is deployed correctly and is fully retracted. And then once the soft capture system is fully retracted, that'll set up the vehicle to put in the hard capture pins. There's 12 of those around the docking ring, and that's what creates that airtight seal between the Dragon spacecraft and the International Space Station. The volume between, which we refer to as the vestibule, is currently not pressurized. Of course, it was just exposed to the vacuum of space until literally minutes ago, about 4 minutes ago. So just waiting for the vehicle to get that.
Dragon SpaceX, ring retraction complete. Docking sequence is holding for MCS reconfiguration.
All right, so we see those ready to hook indicators are lighting up green. So we should be just about to step into those 12 hooks beginning to engage to get that secure mate between Dragon and the International Docking Adapter on the space station.
Wow, right now those two vehicles are flying together. They are attached to each other.
It's been just under 19 hours since we lifted off. We're actually at about 18 hours, 58 minutes, and 42 seconds. So we promised about a 19-hour ride up to station, and we made it just a few minutes before that. They were able to dock a few minutes ahead of schedule. We were tracking them to still take about another 10 minutes, but able to step through all of their burns about 16 minutes ahead of schedule and get us to where we are now. All right, and they did a quick... So the motion control system onboard station now back under those control moment gyros, so handed over from the Russian thrusters, and Dragon now given the go to drive those hooks. We have to do that changeover of attitude control before we drive those hooks, as the Russian thrusters a little bit more dynamic in their control of attitude, and if you had a thruster firing while you were starting to drive those hooks, that could miss a line. So going over to the smoother control moment gyros on the U.S. side, now controlling the attitude on board the station, and those hooks, those 12 hooks on Dragon, about to start driving.
Dragon SpaceX, hard capture complete. Stand by for docking completion.
That hard capture is complete, so that's confirmation of those 12 latches to create that airtight seal. Now that's complete, the umbilicals from the station side will interface with the Dragon vehicle umbilicals, and that'll provide power and communications through space station directly to Dragon. Pretty much the whole way up, Dragon's been using a combination of batteries and its solar cells pointed at the sun to make sure that it has enough electrical power for the journey up.
Just standing by now for that umbilical to get mated, and that's going to Again, as Shiv was just saying, start the power and data transfer between Dragon and the space station. They've been transmitting data through RF radio frequency on the way uphill. And during the final approach, this will give a hard mate, basically a wired LAN connection between the Dragon spacecraft and the International Space Station itself, and then also being able to draw power from the station systems using those great big solar arrays that are used to generate all of the electricity for systems on board the station. And the soft capture system has been stowed. We see the umbilical starting to deploy. About 40% of the way so far, going pretty quickly. Should just take a couple more seconds until we're all the way connected. And then we should be getting that docking complete call out from the core here in Mission Control, SpaceX and Hawthorne. Standing by.
Dragon SpaceX docking sequence is complete.
Dragon, we copy docking complete. To say that it's been a real honor to be just a small part of this 9-year endeavor since the last time the United States spaceship had docked with the International Space Station. We have to congratulate the men and women of SpaceX at Hawthorne, McGregor, and at Kennedy Space Center. Their incredible efforts over the last several years to make this possible cannot go overstated. I'd also like to thank Kathy Leaders and her team of the Commercial Crew Program of NASA. An outstanding job by everyone. Last, I'd like to thank the men and women of the National Aeronautics and Space Agency. This is an incredible time to be at NASA. 3 new vehicles to be flown, continuing mission in low Earth orbit, and then to the moon and Mars. We thank you again and congratulate you.